This PetroSkills PetroAcademy skill module covers process safety risk analysis and inherently safer design at the core knowledge level. In this first section, we will cover process safety and risk-based process safety. Risk analysis is essential for risk management. We will not effectively prioritize without analysis or manage without some form of measurement. No such thing is completely safe, only safer with respect to a defined benefit. Risk-free does not exist. Eliminate a way to go wrong, or reduce the frequency and consequence that is negligible, or manage it for the life of the facility. Why should we spend time and effort on this module? We cannot do effective risk management without good risk analysis, nor can we effectively prioritize use of resources without the understanding of risk that we gain from doing the analysis. It is often said that we cannot manage what we do not measure. In risk management, we need some form of measurement, or at least ranking. Even if we lack the data to make a quantitative estimate, we can analyze sufficiently to help. To do that, we need to understand the risk analysis tools that are available to us. Why do we say inherently safer rather than inherently safe? There is no such thing as completely safe or risk-free. We accept a defined degree of risk for a benefit in everything we do, on or off the job. Inherently safer design seeks to eliminate a way of going wrong, or to reduce the probability and consequence such that the risk becomes negligible. If we cannot do that, we must manage the risk for the life of the facility. Although the name says design, the concepts of ISD can be applied to all phases of the facility life cycle. This module provides a starting point for the development of your understanding of risk analysis and ISD and their applications. This section will cover the following learning objectives: define the scope of process safety, differentiate between risk and hazard, demonstrate and name the pillars of risk-based process safety, and illustrate the relationship between process safety and occupational safety. Like any other field, risk analysis has its own terminology. Until we get the vocabulary right, we can't do much about discussing concepts. Process safety is a focus on prevention and mitigation of fires, explosions, and accidental chemical releases. It doesn't include worker health and safety-related issues. Hazard is an inherent physical or chemical characteristic that has the potential for causing harm to people, the environment, or property. The key word is inherent. If we can't design a hazard out of the facility, which we will discuss later, then we must manage it for the life of the facility. Risk is the product of the chance that a specified undesired event will occur and the severity of the consequence of the event. When conducting a risk analysis, it is important that you go over 3 questions. What can go wrong? How bad can it be? How often might it happen? First, you must identify the failure modes in order to understand the physical and chemical hazards inherent in the materials, processes, and equipment that we are using. Some will be obvious, some not so obvious. After recognizing the failure modes, then you can begin to think quantitatively. In other words, how bad can it be? Finally, you must consider how often the risk could occur. If frequency can be quantified and the consequence defined, then you can quantify the risk of an undesirable result such as fire, injury, or fatality. The first risk dimension is personnel. This is the first concern that usually comes to mind in any process safety incident, and includes fatalities as well as injuries. Major incidents often involve environmental damage due to fire, explosion, and loss of containment of toxic or otherwise environmentally damaging materials. The third dimension, business and financial, involves direct costs, loss of production, loss of business opportunities, environmental remediation, fines, and compensation. Lastly, consider corporate image reputations and the effects of a bad process safety reputation on share prices, recruitment of personnel, and on relationships with regulatory agencies, unions, and joint venture partners. Damage to image and reputation can be a serious threat to staying in business overall. Risk-based process safety follows 4 pillars. Let's take a look at each pillar individually. The first pillar is commitment to process safety, which sounds fairly simple. Although adopting risk-based process safety requires a lot of work and sustained effort over several years in order to make it a part of the corporate safety culture. This also includes keeping it active and alive, and not just a box we have to check off. This is true with any system, but it's easier to audit and control a prescriptive system. If we aren't sure that we can sustain the commitment and keep the system alive, then we are probably better off with a more prescriptive system. This isn't something that we can assume or that should be expected without serious consideration. Every year, there are major process safety incidents that are partly due to lack of understanding of hazards and risks. If we don't recognize what can go wrong and believe that it is credible, we will not be able to effectively manage and eliminate it. Ask yourself this: are new employees trained to understand hazards and risks, or do some follow procedures without understanding process safety reasons? New employees who have a lack of understanding of hazards and risks creates a serious problem in many companies and at all levels. This is clear from most major incident reports, where the cause of the incident is often something that was not recognized as a credible way of going wrong. To prevent this, it's critical to train new employees to understand steps they can take to understanding hazards and risks. Some of many include identifying means to reduce or eliminate hazards, knowledge of process management, as well as hazard identification and risk analysis. We need to also be concerned about complacency among long-service employees. If we no longer take a risk seriously or are used to working around it, we effectively no longer know about it because what knowledge we may still have is not being used. Understanding is not just for new employees, it is for everyone, from the board of directors to the newest employee. Critical errors affecting process safety can be and are made at any level and by people with any amount of experience. If we have the necessary commitment to process safety and understand our hazards and risks, we should be able to manage those risks. Can we assume this relationship? Not necessarily. Although there are very good systems available and many examples of successful implementation, the main problem lies in sustaining effective management. To do so, one can prepare and manage incidents, practice safe working methods, and train. No one facility or company will see enough process safety incidents to provide a valid experiential basis for process safety management. We need to be actively learning and passing that knowledge on. It's said that there are few to none really new incidents, just repetitions of previous incidents with different names and details. If we are to improve, we must learn from the experience of others and not assume it can't happen again. This chart shows the relationship between occupational safety and process safety. Process safety is concerned with low frequency and high consequence. The management of process safety and occupational safety requires different metrics. Therefore, it's entirely possible for a facility to do a good job of managing occupational safety while also doing a very bad job managing process safety. Over the last few decades, the industry has done a pretty good job of improving occupational safety, that is, the accidents that usually kill or injure one person at a time. We do not have enough data to say that our process safety performance is going the wrong way, but there are some good reasons for concern. Our industry has grown usually in quite abrupt spurts that have, at least locally, strained resources. Think of any boom that can and has affected the quality of construction, operations, and maintenance. Much of our installed base is getting old. This is not necessarily a problem if the facility is being well maintained and being kept up to date. If a facility has been chronically under-maintained, it can be very difficult to get it back into good condition. When times are hard, maintenance and engineering budgets and personnel are often reduced. Another factor is demographics. Most facilities now lack sufficient people with the experience to provide effective mentoring for the young people coming into the industry. All of these factors contribute to the risk of process safety incidents. This section has covered the following learning objectives. Define the scope of process safety. Differentiate between risk and hazard. Demonstrate and name the pillars of risk-based process safety. And illustrate the relationship between process safety and occupational safety.